Newton's method. Essential question. How do I use derivatives to estimate a root? We can use our calculators to estimate a root, like this one. We can ask the calculator to give us a root, but it always asks us for a left bound and a right bound. And then it asks us for a better guess, and then it gives us a pretty good approximation. Let's take a look at the algorithm that the calculator uses to arrive at this answer. All right, let's take a look at a curve. We're trying to find the root right here where it crosses the x-axis, where y is equal to 0. And let's go ahead and do this by making a guess. We'll guess that this is the root. We know we're wrong, but we're going to go ahead and guess it. We're going to write the equation of the tangent line. And you can see it has a point. I have the point here, and I have the derivative. Now I'm going to take this tangent line and I'm going to want to find the root of the tangent line. I want to find when y is equal to 0, and I'll call the x that goes with it x sub 2. Now I'm going to solve for x sub 2, which means dividing by the derivative and then moving the x sub 1 to the other side. And this is what we call our second guess. It's a root, but it's a root that's closer to the root of the function. Now I'm going to use this x sub 2, and it's going to be the spot at which I'm going to draw another tangent line. And I'm going to use x sub 2 and the y that goes with it and the derivative. I'm going to find where this tangent line crosses the x-axis, so I'm going to let y equal to 0, and I'm going to call the x that goes with it x sub 3, which is my third guess, or the third root for the tangent line. I'm going to divide by the derivative and then move the x sub 2 over. I want you to notice that there's a pattern right here. Notice that our next guess is always based on the previous guess. All right, and that's what's happening here. This is right here, this is what we arrived at, and I want you to see that the new guess is equal to the old guess minus the value of the function divided by the value of the derivative at that same x value. And that same thing is happening here. It's the old guess minus the value of the function at that guess divided by the derivative of the value of that guess. Okay, let's go ahead, and this is kind of summarizes Newton's method process, where this is the new guess based on the old guess, again minus the value of the function at that guess divided by the value of the derivative of that guess. Sometimes we will have problems with this method in that if you guess, this is your first guess for the root, that guess will take you on a tangent line that will give you a second guess that's further away than your initial start. So the lesson to be learned is to try to make sure you have a better approximation. It should be as close, and if it fails, just try another guess to see if you can get a better approximation or you don't get away from it. Okay, let's actually do a problem. In order to do this problem, we need to have the function, so f of x is equal to x cubed minus 2x minus 5, and then we need to find the derivative, which is 3x squared minus 2. And so our second guess is based on our first guess, which is 2 minus f of 2 divided by f prime at 2. And f of 2 is going to be equal to negative 1, so this will be a negative 1 divided by, and f prime of 2 will be equal to 10. So this is 10, and this amounts to 2.1. So now to do guess 3, it's going to be based on the previous guess, which is 2.1 minus f of 2.1 divided by f prime of 2.1. All right, let's go on to the next screen, and f prime of 2.1 will be equal to 0.061 and f prime of 2.1 will be equal to 11.23. So our third guess, which is what we're looking for, is going to be based on the previous one, which is 2.1 minus f of 2.1 divided by f prime of 2.1. And if you put all these values in, you get approximately 2.0946. All right, let's take a look at using this method to approximate the sixth root of 2 to 8 decimal places. So we're going to be doing this quite a few times. And again, we're going to be using the formula. I'm going to show you how to use the calculator, and I just want to make sure that you understand the function is x to the 6 minus 2. The sixth root of 2 is, this is the equation that'll help you, that solves cube root of 2. And so this is our function, and our derivative will be 6x to the 5th. So we're going to use our calculator to do these iterations over and over again. So here is the calculator, and in y equals, I put my function and I put my derivative. And so now I'm going to go ahead and figure out the value. Now I want to make a guess, and I'm going to guess that 1 is the answer. So I'm going to say 1 is stored into x, and then I'm going to press enter. So that's going to be my first guess. And I know the formula is my first guess minus the value of the function at x, and x currently is 1, divided by the derivative, which I've stored the derivative into y sub 2, and it's going to be at that x. And all of this will be stored into my new x right here. And so I'm going to enter. And then this number is going to feed into, this is my next guess, it's going to feed into, so I'm just going to press enter. And then I'm going to press enter again. And again, the new guess is going to be used for my next guess. And I'm looking for 8 decimal places. So I'm looking for when 8 decimal places don't change. 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, 6, 7. I'm going to do it one more time. And here we go. It looks like these numbers are the same to 8 decimal places. So I'm going to say the answer is this. I can't write it, so it's 1.2246204. And I think those will be the 8 decimal places. Okay, why don't you try the same thing, and this is do the same thing that I did before to try to solve these. Try to find the root between cosine x equal to x by bringing it over to one side, equaling 0. Newton's method is for finding roots, and if you get this answer, you did it right.